join us for this third coffee lecture. The third coffee is celebrating 1 year because we started last year in January, so this is quite an achievement for all of us as a community towards increasing the fair practices within the UN. So my name is Carlos. I'm very happy to be the host of this fair coffee in behalf of the entire team, which is here in the slide. So we are like 8 employees from the UEM from different faculties, and we mostly co-organize together this for coffee lectures. I'm going to give you a very brief introduction of FAIR and the FAIR coffees, and the motivation and how and why we want to become FAIR. And then we move to the main thing of today, which is essentially our guest speaker, which is Michel Dumontier, and we are very happy that he accepts the invitation. Of course, his research is very relevant in the direction towards FAIR, and he's obviously one of the authors of the patterns of these FAIR principles that all of us we are talking about. So he's one and tell you exactly what does mean and how to make your own research FAIR. So today's lecture is about FAIR evaluation tools. So we are going to learn about those services that are very important to assess the fairness of your digital assets. And then we move to a game, a coffee quiz to win a voucher for coffee in Bandidos. So that is going to be for the next hour. So let's go ahead with the introduction. So yes, so let me start here with a little bit of the motivation. So in 2019, the University of Maastricht adopts the overall goal of become a fair university by 2025. So this FAIR 2025 initiative envision the FAIR research data management will provide new methods, infrastructures, and trainings and support service for all the researchers around the university. So we as a community, as individuals, we love data, and we love data science and science as well, and we care about what we are doing with data and other related digital objects. So the FAIR Coffee has the determination to become a unique place where we essentially share FAIR practices within the UM and also outside the university. And we believe that sharing this experience will allow us to increase our understanding of the FAIR principles and how we can implement these FAIR principles in different domains within one community, which type of solution we can get from others. So this FAIR Coffee is about sharing the benefits and also the downsides of these FAIR principles and the experience of implementing the FAIR principles towards increasing our knowledge, competences, and awareness of FAIR and open science. So let me refresh for all of us the FAIR principles. So, of course, the FAIR principle has been widely adopted by very important and range of international stakeholders since their publication in 2016. By intention, the 15 FAIR guidelines principles do not dictate a specific technology implementation, but rather provide a guidance for good data management. So that is the main reason I think that why the communities have the homework to devise, standardize, and implement their own technical solution according with their own understanding of fair to improve the fairness of their digital assets. So, of course, how can we make the data fair? So, in principle, to make your data findable, the data and other materials should be with a rich metadata as well as with a unique and persistent identifiers such as the UI. Also, to get it accessible, your metadata and data should be understandable to humans and machines, and also they have to be provided by open protocol to be interoperable. The metadata and the data should use a formal, accessible, and sure and broadly applicable language for knowledge representation. And to be reusable, data and other collections will have a clear license and provide accurate information of the provenance information. If you want to know more about how to make your data fair, I put the links of the fair data checkers developed by Vincent, which is a software developer in the Institute of Data Science. It's a GitHub page that I can check and click on it. Um, and you can clearly see which type of steps you can do per principle and sub-principle of the four acronyms. Then also I have the original paper from Wilson, and also there is another one which is the Fair Principles Interpretation and Implementation Consideration from 2020, which is another like critical reflection of the ongoing implementation of FAIR and how you can better understand the FAIR principles. We're gonna move to the topic of today, which is the main lecture from Michel Dumontier with the title of Evaluating Fairness. I think that all of us knows Michel Dumontier. So he is a distinguished professor from data science, the Institute of Data Science, as well as from this institute here in Maastricht University. He's also one of the founder of the FAIR principles, and most importantly, he's actually every day contributes to the development of FAIR implementation of FAIR services. So in his lecture, he will focus on the history and the state of art of the fairness assessment, including manual, semi-automatic, and fully automatic approaches, and how this can be used by developers and by all of us. And we will know exactly how can we put in practice for our own research. So that will serve as a community discussion of for how to adopt all these services in our daily basis. So please, Michel, yes.
All right, thank you. Thanks for the kind introduction. Carlos, thanks everybody for being here. It's a pleasure to have this opportunity to present in the Fair Coffee lecture series. There's been some great talks, and it's nice to be invited to be part of it. So for today's lecture, I wanted to focus on some more recent work, but I mean, it's been work in progress on evaluating fairness. And this has been a long-standing topic of discussion ever since the FAIR principles were published some years ago. And I hope to tell you a little bit about what we've been doing in this space and what our colleagues have been doing. So this work that I'll present today is a collaboration with a PhD student, Chang Sun, and also developer in our group, Vincent Dima. As Carlos indicated, you're here, of course, because you have heard about or deeply understand and are working in the space of fair guiding principles. Just to reemphasize, I mean, part of the rationale for developing the principles was really to think about how machines can access the content. And this is increasingly important because, of course, as a data, a digital society, a data-driven society, it needs to be really easy for us to find content and to reuse that content. And arguably nowadays, it's not by sending an email to a friend and say, can I get that data set? It's that the content needs to be available on the web, at least descriptions of it in terms of the metadata, needs to be a clear way to access that content. There needs to be a process by which content that people produce, whether it's open content or whether there are sensitive elements to that, needs to be clearly documented. Organizations need to think about it. So it's sort of like a socio-technological set of principles to advance the discovery and reuse of digital resources that people create. And indeed, it's has been remarkably successful in both the scientific communities, in the sphere of public policy, and of course of our funders and journals and things like that. So it's been exciting to be part of this initiative. And we're just trying to make it as easy as possible for people to make their data fair, and of course to encourage the reuse of that content that other people create. So in sort of the standard workflow, right, this is kind of an overview of what people will do. You have a data set. Typically, people create data, still without it being fair from design from the first point. So a lot of the work that we do are sort of retrospective. The data were created, and now we have to figure out, okay, what is it? How was it done? What are the appropriate formats for that data? What descriptions do we need to provide? And ultimately, how do we make it available? And so this kind of is a workflow. You take the data, you analyze it, you determine the data types and sort of the schema, the relations between the data elements. You tack on a persistent identifier for the data set itself. You want that into a standardized data format according to community standards. You use ontologies and vocabularies to replace your arbitrary textual descriptions with structured controlled vocabularies, and ideally something from that are machine understandable, that they're ontologies and they can be reasoned about. You document that work, those data sets in terms of metadata, and provide those metadata in standardized format. You obtain a persistent identifier for that metadata, and of course these metadata also make use of controlled vocabularies and ontologies. So fair data is standardized data, it's standardized metadata, and in particular to sort of focus or to emphasize the reusability part, there needs to be clear provenance and detailed provenance. There needs to be clear licensing, and you have to sort of adhere to your community standards, right? To what other people expect. But even if I give you this workflow, you're like, okay, well, I mean, some of that is technical, okay. For some people, it's already, I don't really know what I have to do. For even the developers, and they go, okay, but exactly how do I do it? And there's no implementation details provided for the FAIR principles, and that was on purpose. I mean, we knew that technology changes with time, and the technology of today may be different tomorrow. And so we wanted principles that sort of survive the technology churn and basically left it up to communities to think about how they would best make these data available to others. And so one question is, if I have a workflow like the one that you propose, I implement something and I try to create metadata, I try to put my data in standardized format. How do I know that I did that correctly? And so this is the challenge, is how do I know that my data is fair or fair enough? And so what we have to do in this context is, given that we don't have a specific implementation associated with the FAIR principles, it means that there might be a number of ways to implement the FAIR principles. And so when we think about evaluating fairness, we have to be cognizant of the fact that different communities will make different implementation choices, and that any approach to do assessment of this needs to recognize this diversity, which we want to embrace. On the other hand, it has to go through that whole process of standardization, right? It means that You can't just sort of build your own data standard and not go through a standardization process that nobody else uses. I mean, that sort of is not fair data in that context. So the process takes time. Some communities are way ahead of the others. They've been doing standardization work for decades. They have publication frameworks and ways of making content available that adhere to large community standards with regularized data formats and that sort of thing. But many others are just getting started. And so a lot of the papers that we see that cite the FAIR principles are these communities coming together to say, what do we have at our disposal? What are our vocabularies? What are our data formats? What are our metadata formats? And so on. So when we want to do this evaluation, we have to be cognizant and we have to incorporate these diversity of different implementation details as part of the assessment. Okay, so what we started doing, so this was not too long after we published the FAIR principles, we started talking about, well, how do we do this measurement? How do we do this assessment? And we developed a design framework and some example metrics for evaluating fairness. And this framework is quite simple in its idea. The idea is first that when you have a proposal for a metric or some kind of assessment that you want to perform, you have to kind of detail it. You have to explain, what are you trying to measure? Why does anybody want to measure this? What a valid result is from the measurement, and exactly how one obtains it. So what's the procedure to get a value, and that other people who follow this process also will get the same value. So we really wanted to have something of an objective methodology to evaluate the fairness attributes according to the FAIR principles. These descriptions, they need to be clear, right, so that anybody can understand them. They need to be realistic, so most people can implement them. They need to be discriminating, so they don't cover the same kind of thing, but they're actually kind of informative and distinct. They need to be ultimately measurable. There needs to be a procedure to compute a value, and they should be applicable to all kinds of digital resources, right? So when we talk about, we typically talk about fair data, but FAIR also applies to other digital resources like software, like web services, publications, other media types, that anything basically that you can post on the web is potentially subject to the FAIR principles. And so we developed a set of 14 metrics, and the metrics basically demand evidence. So instead of just saying, yeah, I did that, you need to sort of point to a resource on the web that is the evidence for that, by which the assessment will be performed. And so anyways, there are 3 different ways that we can perform the assessments. Okay, so the first is by manual evaluation, so it's some kind of questionnaire. There are semi-automated evaluation strategies, and then there are automated evaluation strategies. So I'll briefly mention the first 2, and we'll focus most of this presentation on the third one. We've compiled with our colleagues at Fair Sharing a full list of known assessment approaches, and these are documented at fairassist.org. Okay, so from a manual perspective, manual assessments, like in the form of questionnaires, interviews, things like that, are super flexible. You can ask all kinds of questions. They can contain both quantitative aspects, but also qualitative aspects. The counter to that is that they take a lot of time to perform the evaluation, and also that people are a lot more resilient in finding information than machines. And I'll show you some examples of that. There are tools like FairDat and FairWare, and of course, data management plans all ask you kinds of questions. They're just kind of qualitative questions. And, for instance, in this form is sort of yes, no questions. In other forms, it might say, give me where exactly is the license document, exactly which standards are you using for your data, what vocabularies are you using, and so on. So it can vary quite a bit what we ask from a questionnaire perspective. In early parts, so when we developed the metric framework, we created a questionnaire and we put it in front of a number of different providers of digital resources like Dataverse, Zenodo, Figshare, Wikidata, and we asked them to provide evidence for the compliance or the adherence to the various parts of the FAIR principles. And typically this would be evidenced by some kind of URL, a location on their website that provides information about, say, the license or the data formats, the metadata standards, the vocabulary used, and that sort of thing. And so in this box, what you see are the metrics that we developed against the data resources. The green boxes tell you that they gave a value, and we confirmed the correctness of that value, and it passes the test. The yellow are things that they gave us, but we had to have a discussion, or there was lack of clarity about what needed to be provided. And then in the red, it's that the test, the value for the test was not provided or was incorrect when we examined it. And so the comforting thing is that there are many green boxes. And so a lot of the information that the FAIR principles expect was somewhat available, but you can see that there's also some, information that were disputed or not shared or understood. And finally, there were some values that were simply not correct or not available. Now, we also took this and we sort of asked the question, could the assessment improve the fairness of the data if we did a test before people got to work and then let them do some work and then do a reassessment? So together with members from GoFair, we were at BioIT World in 2018, and we had a number of different data sets and teams sort of trying to improve the fairness. They used the metrics to do an assessment. You can see sort of a tabulated score. It's a bit arbitrary here, but I think it added up to about 100, let's say 100 points that you could get. And then they did the before, and then they had about, I think, 24 hours to do some hacking, and then they did another assessment after. And you can see that they were able to tangibly improve the fairness of their digital resource by addressing specific points that were identified through the metrics and the questionnaires. So that gave us hope. It meant there is some low-hanging fruit that people could go after in a very short period of time and try to check off more of the boxes for the FAIR principles. Okay, now a second approach to doing this is also the semi-automated evaluation. So like I said, manual evaluations are very time-consuming and they're quite subjective. In semi-automated evaluation, the idea is to mix together computational resources that could automatically extract information as part of the assessment and do an objective assessment there, in addition to qualitative aspects. So together with our colleagues through one of the NIH data commons programs, we developed a tool called FairShake, and FairShake allowed people to create these questionnaires, but then also could automatically retrieve standardized metadata from FairSharing, which had metadata, provides DOIs for a variety of different digital resources and structures this. So FairShake tried to look at FairSharing, extract this out of it, and use it as part of the assessment. So this was nice, and I think this sort of again indicated that maybe it's plausible that some of the information required by the FAIR principles are going to be online, but they need to be in this kind of standardized method. So this was a good start, and simultaneously while this was happening, we started developing an automated procedure, and so automated procedures, the way that they would work is they're fully automated. They're basically machines looking for machine data, extremely efficient in terms of time. It requires all the relevant information to be available in a shared mechanism, which in these implementations are typically what's on the web or through the HTTP protocol. That there is a flexibility also in selecting and applying the metrics. So you can make metric collections and you can choose a particular set of metric profile. Most of the tools are implemented as web applications that take in a persistent identifier and produce some kind of report. How they actually work, you provide a persistent identifier that could be a URL, it could be a DOI, it could be a Perl, it could be any, there's a number of different identifier schemes. They will go out and retrieve metadata about that resource. They will analyze the metadata. They will look for pointers to the data, and optionally will also analyze the data and then generate the report. Yeah, so I think this is a visual, also a visual example. So of the architecture, many of the architectures are, and certainly in the context of our first implementation, is that we separated the metric tests from the applications. The metric tests are implementations of the evaluation metrics that we had detailed before. They're basically standalone programs. They're web services that you can invoke with the necessary input data, and they produce a structured output. And then the application, which is the evaluator, will collect all of the different evaluations and present it in some way to the user. Okay, so the first tool we built was called the Fair Evaluator. And it takes in as an input a URL of a resource, your ORCID ID, and also a brief description of the resource. The output is the result of each metric test, as well as logs. It is persistent, so it gives you a persistent identifier for the result test, so you can retrieve it in the future and refer to it. And you could select a collection of metrics that you want to run against the resource. So the service takes typically between 3 and 10 seconds, depending on how much metadata is available, and processes that and makes it available in a structured format. So this is accessible with that QR code and also the website w3id.org/mifair. M is lowercase in that context. So the user puts in the input data. The fair assessment tool will then will then search a registry of the different services, invoke those services, integrate the results, and present them back in a structured format, and record it also in a registry of these fairness assessments. On the right-hand side, you see basically the report of the Fair Evaluator, simplified, where you can see sort of green dots for where it passes the test and red dots where it fails the test. When you look at the details, here, this is like an example of the details here, then you get a log of what was attempted by the application. But as you can see, it's a very technical sort of detail. It's basically telling you what the tool is doing, and it's more of an execution log rather than something that is informative for the non-expert user, but it really for the developer and for the technical expert. This is informative as to what exactly are the technical specifications that it is attempting to look at and whether it was able to find it or not. So again, what the Fair Evaluator does, and most of these evaluators, what they do is they take that input, they then do some kind of metadata harvesting. So there are toolkits to, first there's a number of strategies to examine where the metadata are located. They could be located in the web page of the resource that's being provided. Sometimes there's redirection, like for instance, when you have a DOI, there's a DOI service that then redirects the requester to the site that ultimately has that content. Same with the handle system. Then there's a set of strategies to say, okay, give me what content do you have available? Do you have content that's structured already that a machine can process, or do I have to look in the HTML? And then you might parse the HTML to see, are there structured content in the HTML? And ultimately, what vocabularies are being used in those HTML or in the structured metadata. And so the evaluators will look at a number of different commonly used vocabularies to examine, to try to find particular information associated in line with the FAIR principles. So for instance, one of the FAIR principles is that the data identifier are in the metadata. And so these are the kinds of vocabularies and the terms or the concepts that specify this data identifier from a variety. So the evaluator looks and says, are any of these vocabulary terms being used? And if so, then examine the value of that. So this is part of the strategy that they have. Automated assessments are rapid, but they're also unforgiving. So if we compare the assessment that the automated tool does against what we were doing manually, then there are differences. And so you can see that in some contexts where there's a yellow box, that's again, there was some uncertainty or maybe dispute about whether the IRI or the information that was provided by the developer was the information that we're really looking for. And the evaluator will look at that and say, that's not what we're looking for. That doesn't fit, that doesn't pass the test. In other cases where the users indicated, so I think for I3 there for Dataverse, they indicated that no, we don't have this information or it doesn't pass the test. The evaluator looks at it and says, yeah, you did. so it's interesting that the humans, they don't always know where the information is and they don't always know how to correctly assess it. But again, the machine is sort of like very methodological and does process the information that's available and returns the results. So interesting that both cases, there might be some dispute, but I think what ultimately happens is that it becomes more apparent to the human developers why the machine cannot find the content that they can so easily see on a web page, that they're not properly documented in a machine readable format. So I think this is really informative for the users. Okay, so the FAIR Evaluator was the first tool to be developed in an automated fashion. There are other tools that are being developed now. FAIR Checker is developed by a French group. They actually use the same metrics. They use the metric tests that were developed in the FAIR Evaluator, but they are expanding and they're sort of trying to evaluate against the community standards, in particular for the metadata that is harvested, and they have a slightly different user interface. Fuji is another tool that's in development, and it has also a very pretty interface to summarize the results, but has a totally different set of metrics that they've implemented in their own code base. So they're not implemented as web services, they're implemented in a single application. In our group, Vincent has started hacking at an evaluator called Fair Enough, and also another tool, Python-based tool to do assessments and implement some subset of the FAIR metrics that were originally developed, with the idea is that we can then build further from this. So let me just briefly explain some of the resources. So I kind of talked a bit about it, but FAIR Checker, one of the important things about FAIR Checker, what it does is it uses validation technology. So the idea is, okay, if you have a particular metadata, or for instance, you have a particular data standard that you're adhering to, then the idea of FAIR Checker is that these metadata and or data standards are expressed in a validation language, like for instance, say, Shackle, which is a validation language for RDF graphs. So it extracts the RDF content from the pages, and then it applies the Shackle validation strategy to say, does it conform with the expectation of a particular community standard for metadata? And I think that's a nice feature and an advance, rather than just saying, are you using the vocabulary of unknown vocabulary? So this goes one step further to say, does it comply with it? It has a very nice interface to explore the results, but it does not provide persistent identifiers or links to download reports in a standardized format. So basically, it's all on the web page, and every time that you want to see the result from a particular page, you have to rerun the whole assessment procedure. Fuji is a tool in development by, I think, the FAIR Consortium. And so they provide, I think I really like their picture, like the illustration here, which breaks it down a number of different metric tests and gives you score for them, and sort of like, says, whether you're sort of like beginner, advanced, or moderate or advanced. It has one of the challenging things about Fuji is that it has a non-obvious way in which the results of the metric tests sort of give you a pass or a fail that's really not clear. So for instance, on the right-hand side, there's a test that says data is assigned globally unique identifier. It has two tests that it does. And if it passes here, it's kind of an or. If it passes any one of these, it passes the test. In other tests, it might be you need to pass 2 out of 3 or 2 out of 5, but that's not clear from that. So it can be confusing how to interpret why did I pass this or why didn't I pass this, because the logic of the tests are not specified. Okay, so we had this week, we presented work at the International Conference for Semantic Web Applications and Tools for Healthcare and Life Sciences, which would have been in Leiden, but it was all put online, unfortunately. And Chung presented this. And so what we did was try to compare these automated FAIR evaluation tools. We looked at a variety of different characteristics of these tools, including the input that it requests, the metrics that they use, the way they present the results, how they present the evidence or what they did, so in terms of an audit trail, through their execution logs or something that's more user-friendly. How the results are made available, whether the source code is available and well documented, and then what the language of the implementation of the tool is. We also tried to look more closely at the evaluation metrics. Again, are they sort of following the set that we set out in Fair Evaluator, which, for instance, Fair Checker and Fair Evaluator are identical in that respect. Or when you look at Fuji, it has its own implementation. There, we sort of look at which sub-principles are looked at by the evaluation, how is the evaluation conducted technically, what content is retrieved, and what vocabularies is the tool aware of. Then finally, we look at the evaluation results from 3 different public data sets. So these are geodata from the Pangea repository, Cord19 from Kaggle, and this NL COVID-19 from the Dutch Institute for Public Health and Environment. Okay, so then we performed the assessments and we looked at this. So this is just a part of our results here. So you can see, for instance, Fuji says, okay, you can put in a persistent identifier or a URL of a data set. For the Fair Evaluator, it says put in a globally unique identifier, and in practice, that includes a number of sub-identifiers, which include URLs, DOIs, and I think there's even some chemical identifiers in there, and also, for instance, Fair Checker URLs and DOIs. You can see different export formats, sort of different level of logging, and so on, different implementation languages. Okay, one of the challenges is that the input, different input of the digital objects. So, and I have it later on, but if you put in a DOI versus a URL, you get a different result. That might not be obvious to somebody who's using those tools. The output, it would be, of course, great if the output of the evaluation is informative enough to understand what was done. What was found and what wasn't, and these are, in very different kinds of technical presentations. In the context of when we look at the evaluation metrics for Fuji, we had 17 metrics to address the FAIR principles, but this excluded 3 of them: the open protocol, authentication, authorization, and FAIR vocabularies. For the FAIR evaluator, for the set of tests that we used, this metric collection, it contained 15 maturity indicators or metric tests that exclude R1.2 and R1.3, which is detailed provenance and community standards. So already, there are different tests available for different parts of the FAIR principles, and that's already challenging. It's a bit like apples and oranges when you sort of look at it. Also challenging is that there are different tests on the data as well as the metadata. And remember, from the FAIR principles, both of them are sort of treated importantly and equally. In most of the principles, you need to examine for instance, the identifier of the data, the identifier of the metadata, the format of the data, the format of the metadata, and so on and so forth. But Fuji only requires the persistent identifier for the data, whereas the FAIR evaluator requires a persistent identifier for metadata and the data, and sort of sees them differently. Yeah, okay, so let's see, I'll just go on here. So here are some examples here of the differences between the different tools. So we look at the geodata for Fuji and the FAIR evaluator. They differ on looking at the findable metrics for the identifiers. Again, Fuji recognizes the DOI for this Pangea data set as a data identifier, but they found that FAIR evaluator treats this as an identifier for the metadata. And this is because when you resolve a DOI page, it is typically going to be not the article itself, for instance, but metadata about the article, and there's a link, a separate link, that points you then to the downloadable content. Also, for instance, if we look at from a reusable perspective, there are differences in the specification of license. For instance, in Cord19, that metadata will specify the license in the field of the license as other. Specified in the description is the value of that license. And while Fuji says, hey, the license was found, right, because the data element was found, the FAIR evaluator says, nah, I don't think so. You're not going to get away with that, right? So we really expected a URL for this license specification. Fair evaluator says we didn't find one, you don't pass the test. Okay, the other thing I sort of mentioned is that, yeah, it matters whether you put in a URL or DOI or whatever it is. So for instance, if you use wikidata.org, fair checker, this is the score profile for that. Somehow it finds information that makes it very positive on the reusable side. But if you give a DOI, which fair sharing provides, then fair checker says, okay, well, the reusable part is very low, but you have a similar profile for the findable and accessible, and slightly less or slightly higher for interoperable. And that's because fair sharing is more about the metadata, of course, for these things, but doesn't provide all the information. It actually confuses the metadata of fair sharing with the metadata of the resource itself. And so when you look at Fuji, kind of a similar thing. If you just put in the URL, you get a much lower score and passing of the test than if you use this DOI from fair sharing, right? And I mean, we kind of expect it because when metadata are registered in some repository and the repository takes care to have a, and present a standardized metadata, both embedded in the HTML page and or through content negotiation, then these fair tools, they look at that and say, great, you did it, right? You provided metadata in the form that we expected, you passed the tests. So it's largely syntactic in this way. We expect that the content is correct, but it's not always correct. And that's one of the challenges that is faced here. Okay, so just wrapping up. Each of the tool really exhibits unique aspects. The Fair Evaluator is really intended to be a community extensible framework. You can build your own metrics. You can build your own metric collections, and then you can apply that to an arbitrary resource on the web, right? It needs to be publicly accessible for this to work. Fuji does a great job on visualization and representation of the outputs. And Fair Checker does a nice job also of making recommendations for failed tests. And I think that's useful for developers that are trying to figure out what's going on here. What do I need to do differently than I've done it currently? Of course, all these tools are under active development and are subject to change. So a lot of these are kind of in their alpha or beta version. And so, yeah, we expect that they will change. The results I presented to you may not be valid tomorrow. The developers are actively working on these tools. One of the challenges that we had is that it's very difficult to understand how each of the tool performs the evaluation. A lot of the time we would have to look at the source code, and if you're looking at Python or Ruby code, you will quickly pull your hair out and go, I don't want to do this anymore, and I don't really understand what's going on. And there's literally no documentation of what the developer was thinking when they're doing things. So it's quite complicated. And of course, that's a limitation of our analysis, is that we can't exactly determine whether they're doing the same thing. It's not particularly clear or easy to make that assessment. We can only sort of look at what we think it ought to be doing with that respect to the information that we can obtain, but sometimes that's quite complicated, especially in the metadata harvesting strategy. Or, for instance, just looking at what technical specifications that they provide. There are apparent differences between these tools. I've presented some of these, both in the, the understanding of concepts about, what the persistent what a DOI represents, where the persistent identifiers are, what are acceptable community standards, the amount of information that's being extracted out of each of those resources, or how it goes and fetches that metadata. And there are, of course, different implementations of the same metrics themselves. And so they might be testing something slightly different. And especially when they are looking for different vocabularies in the metadata, they don't have the same list of metadata vocabularies that they're using. So that means naturally, some of them will pass the test and say, great, you used a community standard. And another one will say, you didn't use a community standard that they knew of. And so I think it's important to emphasize that because these tools are in development, if you're using them to do an assessment of one of your resources, be critical of them, right? Don't just sort of say, hey, I passed all the tests, or I didn't pass some of these tests. But you kind of have to look at the technical specs. And if you think you have a valid objection, like your tool doesn't detect what I'm doing and what my community is doing, then my recommendation is to engage with the developers and have a proper conversation about your standard so that they could extend the tool, because they're not going to be exhaustive, right? They're basically going to be responsive to what communities are interacting with them about. So keep that in mind and work with the developers and try to include that if it makes sense. I think it was really clear from doing this assessment that it's very difficult, like I said, to understand what they're doing. So I think probably what we want to try to do is work on building standardized benchmarks that will sort of say, okay, here is a web page with a particular embedding of the metadata, let's say as microdata, using a particular vocabulary. And let's see if the tool can detect this, right? So establish tests, unit tests for every possible variation of community standards and see how well do each of these things do it. Instead of us kind of doing it on a manual basis, we kind of have to do it on a more exhaustive, comprehensive basis. And I think that would be the main direction for our future work, is to try to establish a benchmark facility so that anybody who wants to build an evaluator, or at least for the existing evaluators, you can say, okay, it does or it doesn't pass these particular implementation approaches. And that might give you comfort as a user to go, okay, it's clear it has no idea what I'm doing, right? It's already been tested, so this is well known. And so that also gives the developers a clear path to improve the coverage of what their tools can find, and also how correct the evaluation is, because we see differences even in a similar metric test, you get a different result depending on which tool you use. We have to get the developers to talk to each other and come up with common standards. Okay, I just want to thank, we had lots of discussions with the developers of those tools as we were doing our work, so thanks to them. And also we obtained funding from Maastricht University, and in particular through the Data Science Research Infrastructure, the DSRI, or compute facility. We get funding from the Digital Society, the Vaccine Digital Society, and from NIH, and as well as from our Horizon EOS Life project. Okay, and that's it. I won't take any more time talking. I hope this was informative about sort of the state of the art of the FAIR evaluators, whether they're manual, semi-automated, or automated, and gives you a sense about what we are doing in our research in evaluating fairness and where we want to go. Happy to open the floor to questions you might have.
Want to learn more about the open science movement and FAIR? Find our next events below.